Yeah, thanks Gaurav for the introduction. So basically now we are going to start with a couple of questions in the next 1 hour. So I've
Okay.
shared the CodePad link in the email and as well in the chat, so you can try accessing that. And if you are able to access, you can share your screen if possible.
Yeah. Yeah.
Okay. So I've pasted the question in the comments at the top of the main function. So you can see that,
Okay.
right?
Yeah.
Yeah, I will
I'm
just
able to.
explain that question a bit. So in this, like we have to design a tic-tac-toe game. So
Okay.
just a second, give me a minute. Mm, yeah. So what we have to do is we have to design the tic-tac-toe game, and there are two players playing that game, and every move is guaranteed to be a valid move. So suppose we are
Okay.
given a n cross n board, and right. So for suppose the first player has his turn, and he will only be able to place his zero or cross in an empty block, right?
Okay.
And we won't be proceeding ahead with the game once any of the player wins. And
Okay.
what are the possible scenarios of winning? Like if any of the horizontal, vertical, or diagonal row has the same zero or cross, then that particular player will win.
Okay.
Right, so we have to implement this class tic-tac-toe, and here we have two functions. So one is the constructor. In this, I'm
Okay.
going to pass a variable n that is going to initialize that board,
Okay.
and the other is move. So in this, we are going to pass row and column, the row and column value at which we are going to place that particular cross or zero, and the player
Okay.
ID. So this value can have value as one or two.
Okay.
Okay, so finally, like this function is going to return three values, 0, 1, or 2. So 0 means that after this particular move, no player has won, right? We will still
Okay.
continue the game. And
Okay.
1 denotes the player 1 has won. And similarly, player 2 denotes player 2 has won the game after this move.
Okay. One thing, Rahul, like
Yeah,
in if player one move is there, suppose.
yeah.
So what sign we want to use or like?
Uh, yeah, it doesn't matter. Like you can use any variable. Like we are not
Okay.
concerned with what is there on the board. Like we are not
Yeah.
concerned about the state of the board.
Internally, we can implement anything. Like
Yes, yes, you
just.
can use any character, anything.
Okay. Okay. And every time any move is called, so it will be a valid. Like
Yes, yes, that is definitely going to be valid. Yes,
so at that row and column, like at that cell, it will always be empty.
yes, yes, and there won't be more than n square number of this move function calls.
Okay. Yeah.
Yes,
Okay. So cross n. Okay.
I can provide you the constraints of this problem. So I pasted over here.
Okay. Okay. So like what approach I am thinking is kind of if I think of a brute force. So like n cross n matrix or array, I will take, and then after every move I will just check like if that like at whatever row and at what column or at that diagonal point, if any of the three is true, that means the player has won, like any of the player, like if one or two.
Mhm.
I will not check the whole matrix as in, but yeah, like if suppose 2 comma 3 is there, I need to make a move, I will make the move, and I will check like if row 2 is fully complete or column 3 is fully complete or the diagonals.
Okay. Yeah.
So for by referring the diagonals, you are saying just two diagonals, right? Just
Yeah, there are two diagonals possible in the matrix.
yeah,
Yes,
okay, the longest diagonal basically.
correct.
Okay, so for that I can just take a helper function and try to figure it out if someone has won or not. Otherwise, I will just keep continuing filling up my matrix with character
Okay.
across or like zero, whatever
Yeah.
I want to choose, and I can do that.
Okay. And what will be the complexity of the solution you can think of?
Okay, so for checking for every chance, suppose there are n square chance max, n square moves are there,
Yeah.
and for every chance, what I'm doing is I'm checking the row n plus n, and then there will be n, like O of n solution. So kind of I can say O of n cube complexity would be there.
Okay.
Yeah. For if maximum n square moves are called, like
Mm-hmm.
there is a case like no one is winning after the n square calls also. So at that point of time, I will be working n cube.
Okay. Okay. And additionally, you will be using the space of n square, right?
No, yeah, for the board, yes.
Okay. Okay. Yeah, this looks a good solution. But can we somehow optimize this? You can any optimization you can think of in this?
Okay, so
So just one thing, like try to think in terms of that we don't need what is the current state of the board, right? So at the end, we are not concerned how the board is looking like. So do we really need to store the complete board, like what all values are
okay.
present in each cell or not?
Okay, like what I am thinking is we can store kind of like just a representative of the row column of every row on every column,
Mm-hmm.
and for that is also for player 1 and player 2. Like what I'm saying is there will be four arrays of size n. So I will store the counts of cross or you can say zeros in that row.
Okay.
So if suppose for any row there is the count that reaches till n for any for 0 or x, then it means for at that point at that row all crosses are there or all zeros are there.
Okay. Okay.
That I can think of as an optimization. So
Okay.
in that O of n space would be there.
Okay. So two arrays for each individual players, right?
Yeah, but for diagonal then, but to check the diagonal it won't be possible. Mm, if I take it some in kind of bits also, but no, 100. You are saying like optimize in kind of like where we are not storing the whole board
Yeah, because if you are using less space instead of n square, right? So you will
automatically
obviously will help in the times complexity as well.
complexity also. Mm, zero.
So I would say like you were going in the right direction for that maintaining of the arrays for players one and two.
Yeah, in that direction, I'm thinking how to check the diagonal, or
Yeah.
I can store six. Uh, there will be two diagonals, so for two diagonals also I can store separately.
Okay.
Yeah, so yeah, then I think it will be. But then also I will be working off n times only. If what I'm thinking is for every row column for player 1, for every row column player 2, and for diagonal.
Okay.
For diagonal, if I store it separately, then I will work O n times only for every move. Then it won't be good. Hmm. What's this? Yeah, okay.
Okay.
Yeah, then it will in O1 time I can find out like if anyone is winning or not. So I will store the diagonal also, like two variables, diagonal one and diagonal two. That the count of diagonal one and the count of diagonal two,
Mm-hmm. For each
and
player
the row.
separately.
Yeah, just in a variable I can just store it.
Okay.
So suppose like if I am making a move in diagonal one.
Mm-hmm.
Okay, diagonal one, if I'm making a move, so there will be diagonal one for player two and diagonal one for player one. So whatever player is making a move, I will increment that count. So there will be four variables for diagonal one and two.
Okay.
And other than that, there will be rows, columns, uh, the whole n size of like I say four into n size of four arrays of n size, two player one and player two.
Okay. Yeah.
Then I will just increment them if any at any point at whatever row and column I will just check it, and in the diagonals also I can check it. Like if the count reaches the n, reaches
Mm-hmm.
n. So that means that the whole diagonal or a row or column is filled with the zero or cross. So
Okay.
I can just say you whoever is
Okay. What is the
there is.
complexity for this then?
That this will be O n square.
Oh, n square. N square is the number of maximum number of moves, you mean, right?
Yes.
So for a particular move call, it is O1.
Yeah.
Okay. And space wise, it is how much?
Space wise, it is O of n.
Oh, okay. Yeah. All right. Looks good to me. If no further optimization you can think of, so we can try to implement it.
Yeah, I think. Other than this, I'm not able to think any further optimization. Yeah, I don't think so.
Okay. Sure.
Any
We can go
further
over.
op-
Yeah.
Yeah. Okay, like I will start implementing them.
You can keep the main function that was there. No? You deleted that, I guess. No?
Okay. There will be.
Let me share that thing. I will paste it over there.
What do you have pasted?
One second. I've just pasted it. You can reuse that.
Oh, okay. Okay. So, this part, so 1 is equals to. I can. What I'm thinking is like in the player argument, you will be giving 0 or 1.
Okay. Yeah, you can assume that. Like instead of that, I was thinking one or two, but zero or one would also work.
Another optimization is I can just take two variable only.
Okay. Why have we removed the two extra arrays?
Actually, I will take the player argument as the row to specify which row it is.
To specify which row is it?
Yeah. Suppose like what I need for a row representing row, I need two row or array of n size for player one and player two counts.
Okay.
So what I did was I am taking the same space, but now I am using a two-dimensional kind of. So 0th will be representing player one, and 1th
Oh,
will be
okay.
representing.
Ultimately, it will be the same space. Okay.
Yeah, space would be same, but it will be like easy for
Got it.
me. I didn't need to use the if and else kind of situation.
Okay. Okay.
Yeah.
Space after that arrow, I think. The first arrow.
You are saying this?
We don't need space, I think. You can remove that.
Uh,
Or you need to import the library, maybe. Just go to the top. Yeah, you can include bits stdio.
why?
Yeah, it's gone.
Hmm. And for this also, I'm thinking of taking a very same vector.
Okay.
Right. Next.
You can take the array if it's an issue because it's a constant size.
Yeah.
I think in this line number 40, so do we want this for loop to run n number of times, or like, you can check?
Mm, yeah, n number of times only.
And in line number 41, for each, like for those n times, we will having a n vector, n size vector.
Yeah, I'm declaring the n size vector. Yes.
So it will be n cross n, right? This row vector.
Oh, sorry. Yes. It's
Yeah,
two.
correct.
Now, if some block is coming, I just need to. So player is either 0 or 1, right?
Yeah, you can take that, not an issue.
Or 1 or 2, whatever you can. I
0
can
or 1
manage.
you can take, no problem.
So then, row player player row plus plus column player. Might come.
You're on mute, Gaurav.
Sorry. Uh, is 0 0 0 side, and then I need to get H1 depends on the player.
I hope array is not a reserved keyword, is it?
No,
Okay.
yeah, I can just modify it a bit. ठीक है, पास करता हूँ. I'm starting.
Okay. So, Boolean flag, yeah, this one. Edit if equal how much? Zero dot size to n. I need to return if it is 0, 1, or 2. Okay.
if winner also the flag throw is there and then winner is the player. Okay, I don't need to do that because
Why are we making this flag true in line 56? Can't we?
like what I'm saying is if at that row I incremented the count of the if it is a zero, like player one will make a zero move and player one zero will make a zero move, player one will make a cross move.
Okay.
So what I'm doing is I will check it like at that particular row. Suppose after making the move, the count of zero or cross is equal to n for that player.
Okay. So
So
can't
then,
we? Yeah.
so at that row, if it is there, if it is equal to n, then that this means that at that row, whole row, either it is a zero or either it is a cross.
Okay. So can't we check this thing when we are just returning from this move function after everything has been computed?
Yeah, we can do that also. No problem with that.
Yeah, because we are pretty much sure that once a player has won, there won't be any further move calls.
Yes. So I am taking a flag as true. So at the end, I will just check the flag and return accordingly.
Okay, sure, sure, you
So
can go ahead, yes.
mm, clear. That's fine.
Line 57, I think, equal to n, we have to check.
Yes. Then zero equal to n or array two equal to n. Then also return if array one returns or array two equal to n. And else return zero. Yeah. Okay. So there is a vector integer. Okay. How do I want this? Zero. Okay, for that I have to zero less than four. Okay, this is an initialization part. I think it is good. Row I equals to vector integer. Or yeah. So yeah, then okay now if any row comes then okay, after implementing this row equals to n. That means the count is players of left through or left through this also and if player is winning of course. So you just calling this dot row dot size. So it will be the repeated. So this will be diagonal one. Second. this is title. So if it will okay, somebody is one then player plus one, or if it is 0 0 2 is there, so that is representing player 0, so player plus one. Okay, there is one and yeah, I think I'm done with the code.
Okay, so you can instantiate the class inside the main function, and I pasted one test case in the chat. Let's create it size 3 initially.
Okay. Yeah.
Yeah, and the test case is like how are the moves going to be? I pasted in the chat, so you can call the move function accordingly. On the right hand side, there is a right, yeah. So you can copy these moves, yes, and pass these values as a parameter to the move function.
Okay. Move.
So we have to
Yeah,
finally
but
return the winner.
okay.
So I think you are
So
returning, yeah.
yeah, what I'm thinking is like if you are calling the move, so the last move you will call, then
Yes.
only it will be a winner kind of case, or
Yeah,
it
yeah, yeah.
can be
We
the
can
case.
assume that, yes. The last move call would be a winner move, basically.
Okay, or either it is a winner move or it is not. Like it can be the case like neither one is winning.
Yes, yes, yeah.
So if last move is equal to 0, then we can print neither wins. Else if this equals 1, out player 0 wins.
Yeah.
Sorry, player 1. Yeah. And two wins. Hmm. Hmm. Should I run it?
Yeah, you can try. Player 1 wins, and what is the expected output? Let me just check. Player 1. So can you just try to answer this as well? Like, what is the expected player who's going to win?
Yeah, I need to check that. Let me check. I will
I will
try
also try
running.
to, because we have changed the variable values from 0 to 1 to 0 and 1, so that's why.
No, it is like if player one wins, I'm taking into consideration that one is there is player one and there is player two.
No, in the move function call, we are passing 1 and 0 as the last argument, right? So 0 denotes player 1 and 1 denotes player 2.
Okay.
So if you can, like, have you thought it the other way around? Like 0,
Yes, like in the printing part when I'm returning it, na, right? Like if
uh,
player one is winning, so I'm incrementing it one.
okay. And in the move function call, it is fine, right? 0 denotes player 1.
Yeah. Yes. Yes.
0 denotes player 1 or player, like 0,
Zero denote player one.
0
Right.
denotes player 1. Okay. So then in this case, the player 1 is the winner, according to me. So let's try to see in which the player 2 wins. Let's try to devise their test case. Mm, so you can draw 3 cross 3 matrix and see if the player 2 wins, how we can do that.
Player two wins, right? Okay.
Yeah.
So we can do like this. We should interchange the one and two part, then
Yeah, that would also work, correct? Yes. So replace 1 with 0 and 0 with 1. Yes.
yeah, then it is coming player two.
Player 2 wins. Yeah, looks good, huh? I think this should be fine. Yeah.
Other than that, I think it's okay. Like we can check this case also because
Yeah, if any other test case you want to check, we can.
yeah, okay. So for 0, 0, if I put as one, okay. Then 0, 2.
2, 2 is
Let's do
1.
this. 1, 1.
Okay, you want to check the diagonal case?
Yeah.
Mm-hmm.
So 0, 0 is 1. Then 1, 1 is 0. That won't work.
You can mark it as 1 as well in 996.
Yeah.
2,
But like there will be alternate chances, so that's why I was thinking it should.
there is no such rule defined, but
Yeah. So I'm thinking like for 0, 0 it is 1. Then 2, 1, 2, 1 it is
0. Okay.
0.
2,
Then 1, 1 I can put it as 1.
okay.
Okay. Then
1. This you can remove.
then
1, 2
for
can
2,
be 1.
2, 0 I can put it as 0. And then at last will be 2, 2. So I can remove this part.
So player 2 would be the winner, is it?
Yeah, player 2 is winning.
Okay, so diagonal, the first diagonal is the 1. that is formed, right?
Yes.
Okay, cool, Gaurav. Yeah, the solution looks fine to me. Uh, so any other optimization that you can think of in this regarding the space wise? Like just give you a small hint, right? Like we are maintaining two arrays for individual players, right? So suppose for the row part, for player 0 and player 1, we are maintaining two oven size basically arrays, right?
Yes.
Can that be done using a single array for both the players?
Yes. Yes, I can do that also. So, like, what I can do is, for player zero, for a particular row, if there it is, I will increment it, and for player one, I will decrement it.
Okay, basically plus one and minus one you are saying.
Yeah. So, if like for any row or column, it is like a case like we need the whole array to be the whole row or the whole column to be cross or the zero. So, if I'm incrementing at some point of time, then decrementing it, so it will never reach in.
Mm-hmm.
At every time in the row, it should increment only. Then only we will reach the winning case for any row or column.
Okay. So you mean that if the row value is ultimately plus n or minus n, then only in that case someone would be the winner.
Yes.
Yeah. So in that, like through that, we can just use a single ON size array.
ON size for row, yeah, ON size single. Like there are basically four rows if you see. This
Mm-hmm.
this is kind of two rows in row
Yes.
and then two rows in column. So then it'll be one rows in row and one row in column.
Correct. Correct. Yeah. Cool. Yeah. That was the solution I was looking for. Yeah.
Yeah, that much automation we can do.
Yeah. Yeah.
Otherwise, I can think of some bit, but bits also it can't be. No, bits it can't be because
Mm-hmm. Yeah. Yeah. We can't.
I can't maintain count in that.
Yes. Yes. Yeah. Let's move on to the next problem because of the shortage of
Yeah,
time. Yeah.
yeah, sure.
I don't know whether we will be able to code this solution completely, but yeah, let's at least devise a pseudo. I'll go for that.
Sure.
So it's a very simple problem. So like I've pasted the question in line 96, if you can see.
Yeah, let me. Okay.
So like we are given a string and we have to rearrange the characters of the string so that any two adjacent characters are not the same, right? So
Okay.
if you are given a string A, B, B, A, right? So you have to organize it the string in such a way that you can make it like A, B, A,
AB,
B.
AB or BABA.
Yeah, somehow anyway. So
Okay.
we can return any
So,
possible rearrangement. That is not a worry.
so is there any case for triple A if it is coming as a string?
Yeah, it can be there. So it is not a valid, right? We can't be rearrange that. So we can return minus one, suppose in that case.
Okay. So the composition of the string will be small alphabets only.
Yes, small characters.
Okay. Yeah. So I'm thinking in a direction like I can store the frequency of from for characters A to Z. Okay.
Okay.
So then I can first check the frequency of the maximum, like maximum frequency what I'm getting.
Mm-hmm.
So if any maximum frequency is greater than the like half of the length of my string only,
Half of the length of the string. Okay.
yeah, so then it is not ever possible for me to like arrange it in a way that every two like no two adjacent characters are the same.
Okay, that's
So
one
some
edge case. Yes.
yeah, so for like triple A, if we see the length is three, or and the frequency is also three,
Mm-hmm. Okay.
or yes, for that kind of case. For double A B also, uh, yeah, yes. So it will be like greater than the half of the length of the case. So it is not.
For double AB, it is a valid case, right?
Yeah, double A B. What I'm saying is 2 1. Then it will be 2 greater than 3 by 2. Yeah, so we can take the like the ceiling of the there.
Mm-hmm.
So if it is a odd like 3 length is there, so it will be 3 plus 1 by 2.
Okay.
So it will be 2, and the length, the frequency of A is 2 there, so it is not greater than 2.
Okay.
Yeah, one edge case I'm thinking of that. Other is okay. So after storing the frequency, we can just I can just subtract the frequency of the next one. Then yeah, I can just take it in a kind of way. I will start with 2 pointers in the frequency array.
Okay.
Okay, so it will be kind of like whatever non-zero is there frequency. So suppose there like we can take an example if for it is like A C D D A A. Okay, so it will be the frequency array will be A B C D. The frequency array will be 4,
Mm.
1, and 1, and then 1, right? So now we can what we can start is we can start with 2 pointers like kind of one is from the starting like that is the A part, that is the first non-zero, then B is the second non-zero frequency.
Mm-hmm.
So after I need to satisfy all A's first. Like I for A to be non-adjacent, I need at least one character in between them, right? So what I will do is I will increment the B part,
Okay.
the second pointer part, till I reach at a point where A is satisfied, like A is fulfilled.
Okay.
Then I can start with B. At that point, wherever my second pointer will be,
Yeah.
then I need to satisfy that. That will be become my first pointer, and then the subsequent one will become my second pointer.
So the array in which we are storing these frequencies, that array is supposed to be sorted.
No,
Okay. Why not? Uh, like, will that suffice if the array is not sorted? Because it may be the case
yeah,
that,
by making it sorted, like it will optimize the solution. Right? Yes.
but if it is not sorted, then suppose the last character is having the frequency that we need to, focus on first, but we will be somehow focusing on it at a later point of time.
Right. Yes. Yeah. Then I think we can store like then we need to sort the array. Yes.
Okay.
Because the largest frequency one element one is the one that will make the problem, or you can say that needs to be satisfied.
Hmm.
Yeah, so after sorting the array it is kind of like for every topmost maximum frequency is there, we need n minus 1 elements of other characters for that.
Mm-hmm.
So I will just sort the array, so it will be like 4 comma a, b comma 1 comma b, 1 comma c, and 1 comma d. So for 4 comma a, I need at least 3 characters different to
Hmm.
adjust it. So what I will do is I will traverse the array till I get that sum.
Okay.
Then whatever left, then accordingly I will process that also. Like so in this, it will be I need 3 characters for that. So I will start with B and I will go through the array till my sum of the characters, like the sum of the frequency is like equal to or greater than the required frequency for A.
Yeah, got that. Understood.
Then for till that part of the array I have done my part. Then I need more like I can say I need to traverse the other part also to check like if it is being satisfied or not.
Hmm. What will be the
Uh,
complexity you can think of in this, or any catch is there in this? You can take your time,
complex
not an issue.
complexity will be like kind of for traversing the array like the string we need the O of n part. Then for space we need O of 1, sorry, O of 26 kind of, so O of constant space only.
Hmm.
And then to traverse the array also it will be like O of 26 only, just like we are traversing the element only once only. So it will be kind of a ON solution with O constant space.
Okay.
Yeah, I think other than that, any solution for this? Like there will be different ways we can do this.
Hmm. Hmm.
Suppose like I can start with the sorted array, so the frequency is there. I will just keep subtracting the frequency till I reach a negative.
Keep subtracting the frequency till it's reach negative. I didn't get that.
Suppose this frequency array will be sorted. So
Hmm.
for this, it will be like 4111.
Yes.
So
Can we take a better example instead of this 4111?
yes,
It's a very simple case to be
A B
considered.
C A B E. So I'm taking a case where it is. I'm taking a A B C A B triple E. So here the frequency array will be first, like without sorted it will be 4, comma 2, comma 1, comma 3. Okay, comma 0, comma 3. So then I will sort it. So it will be 4, 3, 2, 1, 0. So suppose this is kind of an integer array. So I will take the first one and then
Hmm.
subtract the subsequent from that. So 4
Okay.
minus 3, it will be 1.
Okay.
So then again I will move. Then 1 minus 2 is minus 1.
Okay. Yeah. Yeah. Please go ahead.
So minus 1. And then this basically what I mean is I'm thinking kind of that way only. Ki I need to satisfy this character first. So I
Uh,
need 3 characters of others.
okay. Yeah.
So this will be satisfied after this only.
Hmm.
Then
But what will we do with this minus one? Like 4 minus 3 is 1, then 1 minus 2 is minus 1, right? So
yeah.
what will happen after 1 minus 1 is there?
So 1 minus 7. Hmm,
Yeah,
this
let me give you
minus
a
1
hint,
will,
Gaurav, because we are short of time.
yeah,
So here now, so what we have done is like we have created a array of frequencies. So if you can think in like that, like you are thinking in the right direction, that we need to satisfy this 4 first,
yeah,
right? So what will happen? Like we will try to take all these fours first, right?
right.
So I'm just writing it over here. So like suppose the A is having a frequency of 4. So now suppose we use 1A, right? So after that the frequency of A would remain 3 instead of 4. So now the array would be 3, 3, 2, 1 and 0.
Yes.
right? So again we will see that like what is the maximum element. So again the maximum element is still A, right? So
Right.
we can't use A again, so we have to go to the next element.
Right.
So suppose we use the second element. One second. So basically, like we will be taking one character at once, and we have to rearrange this array again and again, right? What is the
Okay.
maximum element at that particular time? So somehow,
Okay.
suppose this value was one second. So let's suppose it was three initially. It was
Okay.
three. Sorry, it was three initially. This was the array, and now we took one A. Now it will be two, right? So we
Yes.
need to sort this array again to make it 3 comma 2 comma 2 comma 1 comma 0, right? So whenever we
Right.
are using one character, we are sorting that array again and again to
That, so I think,
so
yeah, sorting it again.
what we have to do is like we have to take the maximum element out of the array at a particular point of time instead of
We can, yeah, I am thinking of approaching a heap solution. Maybe it can be a solution. Max heap if it is there on the basis of the frequency. So when we are taking out the top one from the max heap, that is, it will come out as 4. Then again another value will, I will pop it out and I will subtract the frequency from that. Yeah,
oh,
okay, sure. Like we can do this also. Like we
yeah,
can,
like I was trying to push you into that direction only. uh, So using the heap only, heap is nothing but the array only, right? So yeah,
right,
we
right,
can
right, right.
maintain the frequency in the arrays itself, in the heap itself.
Yes. So I can just pop it out the frequency and decrement it, and then you are saying to push it again into the heap.
Yes.
So suppose, okay, but okay, yeah,
Yeah. Is that solution looks good to you, like the using the heap solution, or you have
yeah, heap solution is
anything?
much more better.
Mhm. Can you just write a pseudocode for that? Like we don't need the complete code, and just
Yeah,
the normal
so,
comments and function calls you can write.
so suppose I will just write it here only.
Yeah, you can write in the comment section. It's not an issue.
Plus 26.
So suppose like we are having a heap of in the C++, let's suppose we have a structure and
Where did you?
okay,
And it's by default max heap is only.
yes,
Okay. So first I will traverse the string. Yes. Whatever string is given sti not equal to null.
hmm,
I will just and the I equals to 0.
yeah, we can skip these steps, Gaurav. Yeah, like
Yeah.
just write
So in increment
hmm,
the frequency.
okay,
Then after that, then we will just push like for while like for loop till 26. Okay.
mm-hmm.
We can just push it to pq dot insert for that. Okay. So then I will get a heap kind of concept in that. So I can now, while pq is not empty, pq not empty, I will just keep popping out, decrement, insert,
Decrement and insert. So just after decrementing,
until
we will insert
while.
value one less than that, you mean, is it?
Yes, yes. Insert decrement value.
But okay.
Now keep popping until viable option is there. So why viable option is there? I
Hmm.
mean to say, like, I suppose firstly, like, is there any option that I can put it in front of it? Suppose there can be a case like only A is there. So I'm popping out any character with the maximum frequency, and I need to put it to the string, the resultant string. So there should be some different there. But
Yeah.
whenever I'm popping it out from the heap, it will be popping out only A part. A
Yes.
only is there.
Yes.
So then until viable option, if viable option is not found,
Mm-hmm.
then insert, then basically break it or just return
Okay.
blank string. And if it is there, then I will decrement it, insert the decremented value and do it.
Okay. Okay. Yeah, understood. Yeah. So for that, basically, like what we can do is, right, when we popped out the maximum element, right,
Yeah,
so we can see what is the count for that. Suppose 4 is the value for that,
yes,
right? And then again, the heap will be reorganized automatically. And
right,
then we again check what is the max value. If it is equal to 4, then we can pop that out. Otherwise, we can ignore that.
yes,
Yes, yeah. Yeah, I think, yeah, that's the algo, and we can accordingly code that as well. Yes.
yes,
Yeah, I think that should be fine. We can wrap up the interview. I think we are over the time.
yeah. Sure.
All right, Gaurav. Yeah, thank you. Thanks a lot.